Good evening. I'm Spot On Weather Meteorologist Matthew Euler, and we're going to take a look at a weather lesson today on air masses and fronts. Okay, so first thing we're going to talk about is what exactly is an air mass. Okay, air masses play a huge role in what type of weather that we get. No matter where you go, if you were to travel across the United States, there's always various air masses that are impacting our weather. So what exactly is an air mass? An air mass is a widespread body of air with similar temperature and moisture properties. And I did pull that definition from NOAA. And so I appreciate that from NOAA. I want to go ahead and give them credit for that for sure. Now, there are many types of air masses that affect our weather across the United States. And here's just some of the types that we have. We have Continental Arctic, Continental Polar, Continental Tropical, Maritime Polar, Maritime Tropical. And then I just want you to remember as we go through the lesson that continental generally refers to air masses forming over land. So whenever time you see the word continental, think over land. And anytime you see maritime, think over water, because that's where those air masses form. Okay, so we're going to break down the air masses really quick, and I'm going to describe some of their characteristics. First, we're going to start with Continental Arctic. Now, this is a very dry and very, very cold air mass originating from the polar regions. And this is one of the coldest air masses that we'll actually ever experience. When I talk about Arctic Express or Arctic outbreaks, I'm talking about continental Arctic air spilling into the United States, causing below zero temperatures in the Midwest and the upper plain states, and 20-degree below normal temperatures for Southeast Virginia. Continental Polar is more common across the United States, and we experience it here in Southeast Virginia in the wintertime, where we have a cold and dry air mass that Continental Polar typically originates or forms over Canada and moves into the United States. As far as Continental Tropical, this is a summertime type air mass. It's very hot and dry. It forms over the desert Southwest in the summer. You will only see Continental Tropical in the summer over extremely heated landmass areas. And again, that's typically over the desert Southwest. As far as Maritime Polar goes, this is a cold, damp air mass that forms over the northern reaches of the Atlantic and Pacific Oceans. The weather that we experienced this weekend in Southeast Virginia, it is going to be from Maritime Polar source regions. The wind's going to be blowing in off the water from the northeast, and that's going to be bringing in a much cooler, damp feel to the air, and that's a Maritime Polar type air mass impacting the area. So the Maritime Polar air mass actually impacts us quite a bit throughout the year. All right, and then we have Maritime Tropical, which is a very warm and humid air mass that forms over the warmer tropical waters of the Gulf of Mexico and the Caribbean. That's a Maritime Tropical air mass, and that is usually responsible in the summertime for making you feel really sticky and nasty. You're always sweating. It's really humid. The real high humidity, you can blame it on the Maritime Tropical air mass when we get the southerly winds. All right, so now that we talked about air masses, let's talk about what an air mass source region is. An air mass source region is where the air mass forms, and it's a large area with uniform surface properties. For example, it could be a very large expansive area of water, a large expansive area of land, and it's generally relatively flat. All right, you don't want a lot of mountains in a source region because that will help to distribute the heat and the colder temperatures more vertically and lead to greater mixing. So what you really want with the air mass is a flat surface. Winds are generally light and associated with higher pressure over these air mass source regions. That allows for less mixing of the air mass in the vertical and greater stagnation of the air masses over the region. And then air mass source regions, they include Canada. That's a big one for us in wintertime where we get the really cold continental polar air that comes down. Also continental Arctic air way up over the polar regions is another source region. The Gulf of Mexico for maritime tropical air, and the North Atlantic and North Pacific Oceans are also air mass source regions. Right, so here's a map, a picture showing you air mass types, and wherever you see their location, whatever their location is, that's the air mass source regions. So basically air mass source regions is where these air masses form. Okay, so you have continental Arctic air, which is situated well over to the north of Scandinavian countries and over the North Pole. Okay, then you have an Arctic front that separates the continental Arctic air from the continental polar air. Continental polar air is the most common air mass that we see in the wintertime across the United States. It's very cold and very dry. Maritime polar air masses are generally forming over the open, unfrozen waters of the North Atlantic and the North Pacific. Maritime polar, that holds quite a bit of moisture. It's a cooler, moist air mass, that really cool, damp feeling that you get. Continental tropical air mass, again, over the desert southwest, where you have a superheated surface, especially in July and into August over the desert southwest. That's where continental tropical air forms. And then maritime tropical over the basically the southeast Pacific as well as the southwest Atlantic. Maritime tropical air is over the Gulf of Mexico, also over the western Atlantic. And what happens in summertime is the Bermuda High expands. This high pressure system in the Atlantic Ocean expands and moves north, and we typically get a lot of southerly winds or southwesterly winds, which brings up a lot of this maritime tropical air and blows it into our area, making for a very sticky, nasty feeling when you walk outside. All right, so now that we talked about air masses, let's talk about fronts. A front is simply a boundary where two air masses meet. And most of our weather will occur along these fronts because they're separating different air masses as these air masses move. All right, maritime tropical to the north, continental polar to the south. You get these fronts that form that separate these air masses. All right, and usually that leads to some type of storm systems and precipitation and clouds. There are many frontal types. You have cold fronts, occluded fronts, warm fronts, and stationary fronts. And these fronts produce different types of weather, and that really depends on how fast the front's moving, as well as how stable these air masses are. Okay? So here's what you would see on a surface weather map if you were watching TV weather. For example, this blue line with the triangles, the solid triangles filled in, that's a cold front. And behind the cold front, you typically have colder air moving into an area. A warm front is depicted by this red line with half semicircles filled in. Okay, and usually it moves towards the northeast in the United States, and it brings in warmer air. There's southerly winds usually on basically the south side of a warm front. Stationary front really doesn't move all that much. It pretty much is an area where you have the winds blowing parallel in opposite directions to each other. All right, so the cold air north of the front is moving to the east, and the warm air to the south is basically moving to the west. And then you have occluded fronts, which what happens is you have the cold front, which is catching up. The cold air moves faster than the warm air mass, and eventually catches up to the warm air and completely lifts that warm air off the ground. So here's a side view of fronts and the different types of weather you get with it. Just showing you a side view of what it would look like. So for a cold front, the direction of the front is this way from left to right on the screen. Colder air is much denser, and warmer air is much less dense. It's less dense. So as the cold air pushes into the warm air will rise out ahead of the colder air mass. The cold air mass hugs the ground because it's so dense, and it will result in lowering temperatures. All right. For a warm front, what you typically have is warm air being less dense than cold air. As warm air moves into an area, it is so much less dense that it has to rise up and over the colder, denser air mass at the surface, which results in more clouds. And then with a occluded front, in this case, we have a cold air mass behind the occluded front. All right, and there's a colder air mass ahead of it as well. So we have basically what happens is the colder air mass will catch up to the warmer air mass and lift the warm air completely off the ground and push it aloft. And then a stationary front, really there's no movement in between the cold and the warm air masses. They kind of blow, the winds are blowing parallel in opposite directions to each other, so there's no mixing of air masses. All right, so fronts and weather. Just to kind of fill you in on what happens. With a cold front, that typically produces more showery precipitation. Now, showery is the kind of precipitation where it starts really fast and stops really fast. And also it can be very heavy. Possible thunderstorms are associated with cold fronts if the air mass is unstable. The air is going to want to rise. Thunderstorms are more likely with fast-moving fronts, cold fronts, and unstable atmospheres. And with cold fronts that move fast and unstable air masses into unstable air masses, you usually get severe thunderstorms and even tornadoes. So talking about the plain states, that's usually the location where you get these strong cold fronts to push down. Basically, it's a dividing line between continental polar air coming down from Canada, cold, dry air, which is trying to basically push into an area of warm and moist air, maritime tropical air mass. Now, with a warm front, that typically produces steady precipitation, more light, steady precip. If the air mass is unstable, you can still get thunderstorms actually with warm fronts. If the air mass is stable, however, you'll see a lot of fog and that low, dull gray clouds, those low stratus clouds, which are kind of gloomy, make for gloomy days. And then a stationary front, it does not move much, and it produces lots of clouds and steady light precipitation. Fog is also possible along a stationary front. It can hang out in an area for days on end. It can really be a problem for airports. It can actually lower the clouds and reduce visibility with foggy areas, and there's a lot of delays associated with those airports. And then an occluded front produces weather both associated with the warm and cold fronts. So you can have a mixture of both steady and showery precipitation depending on your location. All right, that wraps up the weather lesson on air masses and fronts. Don't forget, we're spot on weather, and please feel free to comment and follow us on Facebook, Twitter, and Instagram. With these weather lessons, please feel free to send us an email and let us know what type of weather lesson you would like to see or hear about. We'll definitely take your requests and possibly put together a weather lesson and put it here on the YouTube channel. Blogs are posted on our Weebly weather page as well. We do occasional weather blogs. And don't forget, YouTube channel has all our videos. And again, I want to say thank you so much for all those that have subscribed. We're up to 21 subscribers now, and I really appreciate it. So that's all I've got for now regarding our lesson. I hope everybody has a great Friday evening and a very enjoyable weekend. And that is all for now. We're spot on weather. If we're not spot on, we're not doing it right. Have a great evening, everyone.